Hey guys, so today we're going to go over a Grasshopper script for generating a tridimensional skin on top of a surface, so basically an articulated skin on top of a surface. I would say that this script that we're going to be using is probably an intermediate Grasshopper script, but we're going to break it down into the basics, so hopefully you'll learn a lot about basic ideas of Grasshopper as well. I have put this in the classes folder, so you if you're taking the digital practices class, you should be able to get in there and download this, both the 3D Rhino model and the Grasshopper script. You should have that open, and this is what this will look like. But for the sake of this tutorial, I'm going to zoom out and I'm going to turn off all the previews for Grasshopper, and then we'll go through them one by one. That way we can see each element. Great. So the first thing I have set up here, I'm just going to minimize that really quick. If I go to my top view here, and these are some ones I made previously, but I have a 30 by 10 rectangle here, and then along this rectangle I have some curves that I've made. So I have a flat curve here, and then two articulated curves, and then another flat curve. And so the first thing we're going to do is we're going to loft these curves just to get our base surface. I also have a point here, which we'll use as an attractor point to modify some of our geometry, but we'll get to that in a second. But if you want to also lay down a point right now, that would be just fine. Okay, so the first thing we need to do is we need to create a curve element. And so remember, to create a component, you can just double click on the space and type in what you need. And then select it here. So we're going to do curve, and there's also panels up here, so you may be able to find it up here if you can't find what you need. But so we need the curve command, and as I go through this, I'm just going through this thing that I already built. I'm not going to rebuild it, but I'll try and hover over each of these components so that you can see actually what it is, because sometimes two components will have very similar names, but they do different things. So you want to make sure that you're getting the right component. So the first thing we're going to do, I'm going to turn this preview on, is we're simply going to set these four curves. So to do that, you would have a curve component, you would right click, and you would set multiple curves. And then you would click on the curves that you want. And then you click enter. And it's going to do a little thinking because it's going through the entire script right now, and that will happen a lot. So if you're opening up a full script, and when you opened up this, you might have noticed that it did some thinking before it generated anything on the screen, and that happens a lot with Grasshopper, and that's why a good Grasshopper protocol is to turn off different parts of your script and only be working on one section, and then to turn on components one after another. It just gives Grasshopper a little bit of a lighter load, and sometimes if it's trying to load an entire script and do all the calculations all at once, it'll actually cause Grasshopper to crash. It'll cause Grasshopper to freeze, and something really annoying about Grasshopper is that if it freezes, there's like really no way to get it back. There's no escape button in the same way that there is with Rhino. So if I click on this now, we'll see that these curves have turned green because they're the curves that we have selected. So that's great. So then we're going to get ourselves a loft command, and we're going to plug our curves into that loft command. And we can preview that and see that we now have a lofted surface here, which is great. And then we're going to get ourselves a surface component. and we're going to isolate the lofted surface that we just got. And so if I preview that, you can see when I click on this that we now have that surface. And it's really good practice when you're sometimes to just pull out your whatever geometry you have and identify it and kind of isolate it like this. You could probably go straight from loft to the next thing, but it's good practice to do this, and it just helps to kind of clarify what you're working with. So one note here, on any sort of input or output, if we right-click on it, we'll see all these options. We can reverse things, flatten things, graft, simplify, reparameterize. So these are a number of different ways of dealing with our data sets, of dealing with the values that make up our geometry, or dealing with different dimensions of our geometry. So I have reparameterized this particular surface, and what that means is the dimensions were 10 by 30, but what I've done is I've changed each of these lengths so that they're on a 0 to 1 scale, and that is a really helpful tool if you ever want to divide a surface up based off percentages. Then you can just use like 0.6, and you don't have to calculate like what is 60% of this particular length, or whatever. So it can be a useful tool in just kind of like giving your dimensions a baseline 0 to 1 spread, so that you can work through them a little bit more. And if that's not clear, it'll probably become more clear the more you use Grasshopper, and the more you start running into different problems with things. So we have our surface, and then the next thing we're going to do, if you see this thing here, we have all these different little pieces. So what we want to do is we want to divide this surface up into a number of subsurfaces that are going to act as the kind of base for these sort of little chopped off pyramids that we're going to be creating. So we're going to divide our surface up. So we'll get a divide domain 2 component. Just be sure to get the right component there. And we'll plug our surface into the domain, and then it's asking for a U and a V count, so it's, you know, that's similar to the X and Y count, but we use that when we're 3D modeling, the U and the V. And so we're going to set this so that it's proportional to what our original dimensions were. So we're going to have 30 by here, and we're going to have 10 by here. And if I preview this, oh, whoops. Oh, sorry, guys. I didn't preview it. I disabled it. But that's something you can do with certain parts of your script if you don't want to have them going on all the time, which is probably something I should do with this one, because as I'm turning it back on, it's trying to fill the entire script out again. Yeah, we'll just wait for a second here. But what we're going to do is we're going to divide this surface up, and it's going to divide it in its head, but it's not actually, we haven't actually like cut the surface yet. So then we're going to grab this it's called Isotrim, but it also says subsurf, so you can type in SUBSRF, and you'll get the Isotrim command, and that'll actually dissect our surface up into the amount of pieces that we've specified here. So if I preview that, you can see that we now have this surface that's been cut up accordingly, and there's a number of subsurfaces here. So I'm going to just be turning things on and off as we go along, but you can see that the divide made all these lines, and then we now have each of these subsurfaces together. So the next thing we're going to do is we want to kind of break down each of these subsurfaces into their different elements, because we're going to use their boundaries to do one thing, and we're going to use their like faces or their actual surfaces to do another thing. So in order to do that, we're going to use the deconstruct rep command, and a rep is just another word basically for a surface. So you'll notice that in Grasshopper that rep is just used. I can't off the top of my head even remember what it stands for, but it's something representation. Regardless, it's just a surface. So we'll do deconstruct rep, and what that's going to do is we're going to connect our subsurfaces to that, and then as we come over here and look at the output we have faces, which are the actual surfaces. We have edges, which is like curves around the boundary, so we have these square curves, and then we also have vertices. So if I were to show this, we have these little X's here where the vertices are. So then we can isolate each of these three things and use them to continue building our surfaces. So we're gonna look at the surfaces first and what we're gonna do with those. So if I preview that, we can see we have all these surfaces, which is great. Oh, okay. Well, so yeah, so we have the surfaces, we also have the curves. If I turn this on, you'll see that only the boundaries of these surfaces light up. So we basically have, I think we have 4 edge curves, 1, 2, 3, 4. So the first thing we're going to do is, since the edges are all separate, we're going to join them. So we're going to get the join curves command, and we're going to plug in our curves. And then that will create, you won't really be able to see the difference, but it will create a number of squares. So if we look here, we see in the dialog box we have 1200 here, but then once we do the join, it combines all 4 of those, and so you can see that we only have 300 locally defined values over here, and that's because we've joined each of those segments into a square. So we now have squares instead of just lines, which is great. And the next thing we're going to do is we're going to offset these squares. So basically what we're going to do is we're going to take one of these frames and we're going to create another one that's kind of inside of it, basically. And that's going to act as the base of the geometries that we want to create here. So if I look over here, you can see that we have these rectangles that are serving as the base, and that's what we're about to generate right now. In order to offset this, we're going to get the Offset on Surface tool, and we're going to plug in our curves, C, and then we're going to select a distance that we want to offset, and I would set this pretty low. Just use grab a number slider, so you can type in slider, and then you just want a number slider. And remember that you can always rename any element, so you can see how I've renamed the slider distance by just right-clicking on it, and then typing in here, whatever. And then it says whatever. Other things about number sliders is you can edit them. Well, there's a few different slider types. So there's a floating point, which will be decimals. There's integers, which will stay as integers, and then you can do odd numbers or even numbers if that was something you wanted to do. Floating point is mostly what we're going to be using for this one because we really want to get that precision. We'll be working with small numbers. But you can go to edit here, and you can change the minimum amount and the maximum amount, the range. You can change the name, so you can change whatever you want by just right-clicking and hitting edit. And then one last thing about number sliders before we move on is if you want a number slider but you want it set up exact, like you want it set up within your range on the exact number that you want, there's a little shortcut command, so you can double click, and then let's say I want a number slider that's between 0 and 20, and I want it set to 4.3. So I can type in 0 is less than 4.3 is less than 20. Boom. and now my slider shows up exactly how I want. I don't have to go in and change it. It shows up exactly the way I want it to be. And you can see that it's staying in the 10th decimal place because that's the decimal place that I set it in. So that's a shortcut for creating number sliders really quickly. So we've got a distance for the amount of offset that we want, and if this was a negative number, it would offset the curve outside, so we would get a bigger frame, but we want a smaller one. If it's ever on the wrong side, you can just make the value negative and it will go to the correct side. And then the last thing it's asking for is a surface for offset operation, which basically says, like, where should I put this new curve? And we want it to be on the surface that we created, which is right over here. One other thing you'll notice is in between these two steps, our lines changed. So what's that about? What happened here was that we had a number of subsurfaces, and they were all in just one list or whatever. But then we broke this down into all these different categories. And when you do that, you'll see this double dotted line here. And this just has to do with the way that your data set is set up now. So we have a number of, instead of having one list of subsurfaces, we have a bunch of lists that each have a couple components each within that list. And I'm going to talk a little bit more about the structure of data sets that are held within these components a little bit later. It's a really important thing to know when doing Grasshopper, and it's also a difficult thing to know really well. Like, I still don't quite know all the time what my data set looks like, but we'll go over a few different reasons why it matters and how we can change things if we find that something's not working. Okay, so regardless, so we're going to offset these, and then we're going to pull out the curves. So if I turn these on, you'll see that we have offset this frame inside of itself, and it's sitting on the surface, so we now have a smaller frame. And so that's going to be the base of these guys over here. So, great. So we now have that. The other thing we want to do is we want to, basically what we're going to do, as you can see from these guys over here, is we're going to like push geometry out of this surface. But we want the geometry, like, we could extrude this, but when we extrude it, it's just going to extrude straight up, and that's not what we want. Like, as you can see here, we want the geometry to pop out, like, directly out of the surface wherever it is, depending on its curve, you know? So we want it to pop out perpendicular to the surface wherever it is, and not just straight up in Z space. That's how we get these nice articulated surfaces. So in order to do that, what we have to find is the normal of a surface. So the normal basically means the vector at a certain point on the surface that points straight out from that surface. And so in order to find the normal for each of our subsurfaces that we were working with earlier, here we have to evaluate surface. So I'm going to hover over this. So we need an evaluate surface component. And then we'll connect those subsurfaces that we had before, that we got from the deconstruct rep, and we'll connect those to the surface input. And we'll also right-click on it, and we'll reparameterize it. So why are we reparameterizing it? Remember that I said that reparameterizing it takes the dimensions of something, no matter what they are, and it remaps them from whatever their range is to 0 to 1. And that's important specifically for this guy here. So what the heck is this thing? So we have our number sliders, right? You've seen those. They're great. Well, this is what we call the multidimensional slider. You can just type in MD slider. And this is just a slider for orienting ourselves in a two-dimensional space. And the reason we're doing this is because evaluate surface asks for a point at which to evaluate on a surface, right? And so we have to tell it where that is. So we reparameterize our surface so that each edge is going from 0 to 1. And then on here, we set the MD slider to be halfway down this edge and halfway up this edge to a 0.5, 0.5 location. This basically means that it's finding the center of our surface and it's analyzing and evaluating that point, which is exactly what we want. We want to find the normal at the very center of our subsurfaces, and then we want to project our geometry straight up out of it. So we could move this, we could pull it over to this quadrant or whatever, and what would happen is the direction in which our little pyramids would be going out from the surface would be skewed ever so slightly. But we're going to keep it at the center of the surface. So we've got that. And then what we get out of the evaluate surface, it's kind of like the deconstruct rep, is we get a number of different components. We get the points at the place where we evaluated, so we get some points here. We get the normal, which is exactly what I was talking about earlier. This is the vector that tells us which direction is straight out from the surface at that particular point, depending on the curvature of the surface. And then we also get the frame, which we're not going to be using, but it could be helpful for something down the road. So if we look at this, you'll see we have points at the center of all our subsurfaces, because that's what we set it to, which is great. And then we also have our normals. Now our normals are coming in a lot bigger than we want them to, and we're going to be using this vector value to project the geometry upwards. But if we use the normals as they are right now, they're going to project the geometry like way up, like way too far up. And so we need to dial it back. So what we're going to do is we're going to do a little multiplication to get these vectors to be a value that we can actually use so that we can then move these things. So we're going to get a multiplication component here, and we're going to get a number slider. And I have mine set to negative 0.341. And so, and you might be wondering like why it's negative. So I'm using a negative fraction here because I want the normal vector values to become smaller. But what also happens, which you would notice if you used a positive value, is that what it'll actually do is it will project our geometry out the other side of the surface. So when I set this up and I had a positive number, it was projecting all of the geometry underneath the surface, which I don't know why it chose to do that specifically, but in order for it to project out of the other side of the surface, I had to make it negative. So we're going to use a negative fraction here to minimize our normal values and put them on the correct side of the surface. And then we're going to use that to move our frames upward. But before we do that, let's go back to the points here. So we have all of these center points here along our surface. But maybe we want to do is we want to show a particular pattern that's going across this. So if I come back over here, you'll see that I have two of these that have been made. I have one of these where every single shape is exactly the same size, and then I have one of these where it seems like these shapes kind of flatten out in this area. And this can be really great for showing relationships to a certain point. And so we set up what is called in Grasshopper an attractor point. And what that does is we can set up an attractor point, and then we can measure the distance of all of these center points that we have to the attractor point, and then we can alter their geometry proportionally based off of how far they are. So you'll see if I go in here, that the tops of these are itty bitty, and that's because they were really close to the attractor point, and then the tops of these, the ones the farthest away, are really large. And so you see there's proportional manipulation of the geometry based off of the distance from the attractor point. And these can be used to set up all kinds of things. You can use an attractor curve, so I could set up a curve and have this kind of flattened area going all the way down this or something. So attractor points and curves can create some really, really beautiful and interesting patterns and paving patterns and things. I would encourage you to look up attractor points on some of the Grasshopper resources that I'll be providing, because there's a lot of cool things you can do with them. So, attractor point. We're going to set this up. So we're going to go back to these points that we pulled when we evaluated the subsurfaces. And remember, they were our center points. So we have those, and we're going to then, if you remember, I had this point here that I had given. So if you don't have one of those, please just create a point somewhere like on your surface or right below your surface right now. And that'll be our attractor point. So we'll just get a point thing, and I've renamed mine to the attractor point. And we'll set that point. So set one point and then click on your point. And then we're going to find our distance between those points. So you'll use the distance component, and you'll pull in those center points and then the attractor point, and now we have the distance between all of these. And you'll see that what I've done here is I right-clicked on this output and I flattened it. So what flattening does is it, before this, remember I said, because we have this dashed line, we basically have like all these separate lists of values, and each of these lists has a couple different values within it. That's just how we've been holding the values of our geometry. But we want to just get one big list with everything. We don't want them to be in all these sub-lists, because we don't need that for this. We just want to get one big list of all the distances, and then we want to use that list. We don't have to sort out through all the sub-lists. So because of that, I'm going to flatten it. And the opposite of that, which we're going to do in a second, is to graft it, which means that you package all those separate values back into separate lists. And the use of grafting is that if you had corresponding geometry, so let's say we had points and surfaces that we were working with. We took these points down and we manipulated them and put them through a bunch of things. But in order for them to find the surfaces that they were corresponding to way back when we first separated them out, we have to graft this, and so they're each in their kind of like little separate compartment, and they can find the corresponding compartment of the surface. Grafting and flattening and all of this can be really confusing, and sometimes if a script isn't working, the best thing to do is just to try and graft it or try and flatten it, and you might get what you need. I've started to understand it much more after using Grasshopper for a while, but still sometimes I just experiment and it works, and that's exactly what I needed to do. So when in doubt, maybe just try it out. So anyway, so we've got our distance, we've got a list of distances of each of these center points to our attractor point. And the next thing we're going to do is what's called remapping. So we've actually done some remapping before when we parameterize things. So you know how I said that parameterizing takes the dimensions of something. So let's say we have a dimension, we have a length that goes from 0 inches to 30 inches, right? And it changes that the values of that to go from 0 to 1. So that is an act of remapping. Remapping takes the range of any data set and it remaps it into a different range. And this can be really helpful when we get distances when we have numbers that we want to use but that they're like way too big for us to use. For instance, our distances here. So we have distances of like 15, 16 here. And we want to use that, we want to use those distances to scale the tops of our geometry accordingly and proportionally, like I was showing you earlier. But if we scaled this by 15, we would get these humongous tops of our geometry. They would be way big. It would be all distorted and it would be crossing all over each other. And that's not what we want. So we want to take the range of our distances and we want to minimize it down to a smaller range. And it's still proportional, but it's just at a smaller scale. And so we do that by remapping. And this might make more sense the more we go down, but this is a very typical group of components that are used for remapping. So we get a remap numbers component, and it asks us for the values, so those are the distances that we have, and then it asks us for the source domain. So domain is another word in Grasshopper for range, the range of a set of values. And so in order to get the domain of our distances, or the range of our distances, we grab what's called a bounds component, and we plug that in, and then this gives us basically a range. So you can say here that we have a range from 1 point blah 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 to 16 point blah blah blah. So it gives us our range in a way that we can use. So then we plug that into our source domain, and then it's also asking us for a target domain. So we have to set up what we want that new range to be. So in order to create a new domain, we have to construct it. So we're going to create a construct domain or component, and make sure that it's the correct one. There's a two-dimensional construct domain, and there's like a one-dimensional one. The two-dimensional one has like a squared on it, so just make sure you're getting the correct one. And then we're going to get 2 number sliders, and I set the start to something very small, 0.01, and then I set the top to 0.8. And so that's constructed our new range of values that we're going to be putting our squeezing our distances into, and then we'll set that into there, and then we get all these remapped numbers. And then, like I said, we're going to graft them because we want to take the information of all these points and we want to put them back in their own little subcompartments so that we can then use those subcompartments and align them with the kind of like I'm saying subcompartments, I mean like sublists of data, and we're going to use that to align them with the curves and the surfaces that we created earlier. So it basically keeps the information of this center point, and it allows us to then find the information of the boundary, because otherwise we wouldn't know which center points correspond with which curves unless we regrafted it backwards. So yeah, it takes some getting used to, but hopefully that at least gives you kind of an idea of what we're doing. So we've done our attractor point thing. We have all these remapped values. So let's go back to our curves that we made. These were our offset curves. Remember when we did that? We've offset the curve inside, and now what we want to do is we want to create a new curve. This is the bottom of our geometry. We want to create one that's the top. So we want to scale it according to how far it is from the attractor point, and then we want to move it up in space according to the normal that we found. So let's do that. So first we're going to get a scale component, and it's going to ask us for our geometry, and we're going to plug in these offset curves, and then it's going to ask us for our center of scaling, which is our center points, which we found thanks to the multidimensional slider. And then we need a factor at which to scale. And so we have all of these great remapped distances from the attractor point, and so it's going to scale these accordingly. And if I turn this on, you'll see that we have all these scaled frames, and that as we go away from our attractor point, they get bigger, right? Okay, great. So these will act as the top of our geometry, but in order for them to be the top of our geometry, we have to get them off of the surface and up into the air. So we're going to move them. So you're going to grab a move command, or a move component. You're going to set your scaled frames. See that? And then it's asking us for the translation vector, which is the normal vector that we found earlier. So remember, we found our normals because we evaluated the surface. We minimized them a little bit so that they'd be useful. We also made them negative so that they'd be on the right side of the surface. And now we're going to plug that in so that we can move these guys up into space. Now you can see that they're up there floating. Yay! I'm just going to turn these guys off so you can really see that. So yeah, so now we have our offset curves, which are our base, and then the scaled lifted curves, which are going to end up being the top. Let's see here. So then in order to create geometry that connects from our base to our top, we're going to merge these two lists of curves, these two sets of curves. So we're going to get a merge component, and then we're going to plug in our base curves, our offset base curves as D1, and we're going to plug in our lofted top curves, which I've pulled out into a curves component, and then we're going to plug that into D2. And the important thing here is, in order for them to find each other, in order for this frame down here to find its matching partner up in the air, we have to graft our values so that they go up into separate sublists, and then this corresponding sublist can find each other. So we merge those, and if I preview this, you'll see that we now have both the tops and the bases selected. And then we will loft them. So you'll get another loft component. You'll pull these guys into the loft component. If I preview this, hey, oh my gosh, we have geometry. So we're getting close. Look, this is like pretty close. Things we still need to do. We still need tops for these. We don't have those. They're just open right now. And then all this extra space in here isn't filled either. So let's go back and let's do the space in the middle first. I'm going to shut this off just for clarity's sake. So in order to get the spaces in the middle, I'm going to also shut off these guys. So in order to get the spaces in the middle, we have to create a surface between our original subsurface frame. When we very first cut this up into pieces, that frame, we need to create a surface between it and the offset curve that we made before. So just like we merged the base and the top of our geometry, we're going to merge this outer and this inner frame. So let's get another merge command over here. And I know this is kind of looking a little messy, so you just have to be really careful to organize your components as best you can so that it's as clear as it can be, because sometimes it can not be very clear. So we have another merge command. We're going to grab our offset curves, these guys. We're also going to go all the way back here and grab those outer ones that we joined together. We're going to plug both of those into this merge. And remember, in order for them to find each other, in order for this frame to find this frame, we have to graft so that they go up into their own little separate subcompartments, and then those subcompartments can find each other. We also did something called simplify to each of these, and that just gets rid of any redundancies. It really can't hurt, so we're just going to do that. And remember, to do any of this, you just right-click on an input or an output, and you click on this. So we've merged these guys, and now we're going to loft the space in between. If I show you that, okay, great. So now we have these surfaces here. So this is actually kind of cool. This could be cool in itself in that it's like a kind of like a frame or a fencing almost. So that could be useful in its own right if you were doing something like that. Remember that we also have this geometry. So we have both of these at the moment. And the only thing we don't have are caps. So we need to cap our geometry. And this is kind of going to be, this is a little annoying that we have to do this, but just bear with me here. We're almost there. So in order to cap our geometry, we're going to take the top curves. Remember these guys? The ones floating in space? These are the things we need to create a surface in. But we can't just create a surface in them because Grasshopper has a hard time creating a surface in, with a boundary that is curved, which all of these you can see are these curved boundaries. And so in order for it to create a surface, we have to break this frame up into 4 different pieces, into 4 different edges. So we're going to get an explode command, and we're going to put our curves into that. And what that gives us is the segments and the vertices. If you need those, we just need the segments. And then we're going to plug this into this really handy component called a list item. I'm going to show you guys this. So you'll see when you open up a list item, you just have item I. In here I have 1,200 different values that are in these 4 different lists, list items. And so you can create a number slider. Basically what a list item does is it allows you to grab a specific item out of a list of geometries or a list of values, which can be really nice. So I would create a number slider here and plug it into I. And if I said 7 here, then I would get the 7th list item here. But the other thing, shouldn't have deleted that. The other thing you can do is you can zoom in on this guy, and you can add 1, 2, 3, 4, and that's exactly what we're going to do, because we want to get each separate curve out in itself. So you can just zoom in and add those, and then if I created a curve component and I showed you this guy, preview that, you see that list item 1 contains all of the edges on this side, right? They're all in their separate lists because we have this dotted line, but they're all kind of gathered together. If I were to pull this guy up, we would see we get this side. If I pull this up, we get the bottom side. If I pull this up, we get that side. So we have all our sides, and then we're going to basically create a surface from those sides. So we're going to get an edge surface command here, and when you get that, you'll probably, there are 4, great, okay. So if there weren't 4, you could always come in and add one by zooming in, and then you just pull these over, and then it creates a surface out of those edges. Great, so we have our caps now. Yay! So what do we need to do now in order to get this all to be one surface like this? If we baked this now, we would get a bunch of caps, a bunch of geometries, and then this like inner framework. But we want it all together as one surface. We don't, because we want to just be able to drag it and move it and do whatever with it. Maybe 3D print it. So we're going to do a final merge. Get your merge component. We're going to pull in our lofted framework that we got back here. We're going to pull in our lofted geometry that goes up. And we're going to pull in our edge surface caps. We're going to pull them all in. And we're going to merge them together. And then we're going to, so these are all kind of in like one big list with a bunch of sublists, but it's all kind of combined now. And then we can flatten all of these different pieces down into one big list. We just want one big list with no other organization, and then we're going to join these things together. And by joining them together, any surface that is touching any other surface will connect to it. And so with that, we get just one single surface, and then as I've noted so nicely here, we can bake that shit and make it real. Oh, it's a good feeling. We made it, guys. So you can right click on this and you can bake it. It'll ask you for the layer. Pop it on here. Okay. It's gonna do it. Oh my gosh. Okay, so it took forever, but look, this is pretty freaking cool. So yeah, that's the gist. It was a pretty intermediate Grasshopper thing. So great job for having the patience of going through it. I hope that you've learned a lot. And you can always keep referring to the script and the notes I've made. It'll keep making more sense each time you do a new Grasshopper thing. But remember, each of these is its own action. So you have to start thinking about geometry and its pieces and how you can use certain geometries to create other geometries. So start thinking through, as I've made this, start thinking through the logic of how you take one piece of a geometry, the boundary of something, or the fill of something, and you transform it into another piece of something, and then you might connect those pieces, right? So it's actually a really great, Grasshopper offers us a really great way of thinking through geometries and thinking through process. So it can be a really powerful tool. We just have to have some patience with it and get used to it. But yeah, so that's making a tridimensional skin. And if there are any further questions, you can always email me, and we'll also try and have an in-person tutorial here very soon. All right, thanks for sticking with me today, guys. We'll see you next time.